Today I'm going to discuss about how to call SNP from the transcriptome data. In last some videos I have discussed about how to import your raw data. There is Illumina forward sequence and reverse sequence. After that how to trim that data using this software called Trimomatic. So after trimming you can see it generated two files R1, R2. There is our trim sequence. What is the parameters for trimming that all this sequence? It is there in my previous video. You can see that. So now we have our trim sequence. After that I also made the video for de novo assembly. If we working on the model organism for which the reference genome is not available, for that purpose we need to go for de novo assembly. I have made that video how to do de novo assembly also. So after de novo assembly of the trimmed raw data, you will get that assembled contigs. So at assembled contigs that are large size of sequence that is generated from the small size of these that assembled together, and this, these contigs are made. After that, we need to map that contigs. We need to map all the reads with that contigs. So for that, we can use the software called BOTI. BOTI is the software which used to map all the reads with the contigs. As we don't have our reference genome, so we can use that assemble contigs as a reference genome to map our reads. Okay, so that will generate one BAM file, and that BAM file can be used for calling the SNPs using this FreeBayes software. Here I have used FreeBayes software. There are different software also, VARScan or SAM tools that can be also used for SNP calling. So today I am going to discuss how to map the reads with the assembled contigs. So for that purpose, you have to go to the left side. You have to come to the option mapping. Okay, click here. So just scroll down. You can see here is map with VOTI for Illumina. You have to select that. I'm selecting that. From here you have to select the history. From here you can select your reference genome. That is our assembled contigs. Okay. After that you have to select parent as our data is power parent. Go to parent. After that you select here your forward sequence, trimmed, reverse, trimmed sequence. Okay. After that simply execute that. Okay. After I have done it already, after clicking execute, it will start running. Okay, here you can see my this mapped file is generated here. After execute that, it will start running and it will generate that file like this. Okay, so now it is a BAM file. This BAM file can be used for calling SNP. Okay, so our assembled reads assembled context is now our reference, and with that we are mapping our all small size reads. So depends on the variation in the nucleotide when compared with the reference, so it will give you the SNPs. Okay, how we can do that? For that we can go to this option variant calling, scroll down, VARs can also there you can use. Here I used FreeBayes. You can go to this FreeBayes. Here what this is very easy. What you have to do here, you have to select this history. From here you have to select that BAM file and your assembled file as a context. Okay. After that, here are different options you could choose based on your needs. Here I am choosing simple deploy calling, so it will call you data. After that, you can execute from here. Okay, click here and it will start running, and depending on your data size and internet speed, it will take time to execute that. Okay, after processing, it will generate this file, that is variant calling file. So from here you can download it, as I saw in my previous video how to download that. Okay, it will come in this bcf file, .bcf file. Okay, you can download this file from here. Okay, after that download, I have downloaded already that file. So that file will looks like this file format. Okay, bcf and all this thing, and all the context information you can see here, and all the info you can see here from here, different coverage and the number of altered base and all these things info. After that, this is your SNP types. So this is a chromosome number, so it is identity of your context. After this position, this position came here 105 ID, they gave something. After that, reference base is here, or A, altered base is C. Okay, this all these headings is some skip to this left side, but if you open in Node plus 22, so it will be properly arranged. So reference, this is our reference, this is our alter. So this way you can see all the SNP that is generated. Okay, similarly I have discussed how to generate SNPs also using VDAP software in my previous video. Here it is another way you can use this transcriptome data to call SNPs from Galaxy server using FreeBayes software. It is online, but BDAP needs Linux system to run and commands also, some commands to run, and that BDAP also needs some dependency like active file and Java. Okay, so Linux system is needed for that, but you can use this Galaxy server from Windows also, and as well as from Linux also, any system, because it is online, so you can make use that. Okay, so for today's video I have discussed how to align, how to map your reads with the assembled context, and how to it will generate the BAM file, and how to use that BAM file to call SNP. I have discussed today. I think this will be very helpful, and so so this is our file now. So in later video I'll discuss other softwares also, and there in the left side you can see other software also available for variant calling, like VARScan you can also use. So it's also some, you need to do some previous work for this VARScan. So later on I'll discuss about how to use VARScan for variant calling. For today I used the software FreeBayes. It is also very useful software. We can use some tools also. Okay, and thank you.